In the last class, we have seen electric field due to a dipole on the axial point. Now, this is another situation in which the point is given on the equatorial plane, not on the axial line, but on the equatorial plane. So, I consider a dipole with positive charge and negative charge separated by a length 2a, and from the center of the dipole, I consider a point P, and that P is at a distance r from it. Now at this point I have to find the net electric field. So the electric field is due to this charge, positive charge at this point, and the negative charge creating electric field at this point P. I will find them separately and I will try to add it vectorially so that I get the total electric field at the point P. Now you see this figure, you have the same charge positive and minus Q separated by a distance 2a. So to the middle point, if I consider the middle point a, this is the length, from here also a is the length, so that the total length is 2a. Now P is the point at a distance r from the center of the dipole where I have to find the total electric field. So this length from the positive charge to the point P, the length will be root of r square plus a square. This is from the Pythagoras theorem. Consider this as the triangle. So r square plus a square is equal to this length square. So this length will be root of r square plus a square. Same is the length here because this point P is exactly at a distance r from the center. So this length is again r, this is a. So this length is also root of r square plus a square. Now the angle dipole makes with the point P from the positive charge, I make it as theta. One more thing, we know the electric field at the given point due to positive charge is away from the charge. So it is acting away from this charge. Due to the positive charge, so I mark it as plus, E plus. So to the at the point P, electric field due to the negative charge minus Q, which is minus E, is acting towards the charge. You see this arrow mark? This electric field is acting downward through the line connecting the point P and the charge. So two electric field, one is acting this direction, one is acting this direction. Now if I draw a line here which is parallel to this charge dipole, here these two lines are parallel, so these angles will be equal, and these two angles also will be equal, so that if this is theta, this and this is theta, this is also theta. Now let me find the magnitude of the electric field, the value of E plus and E minus. I don't take the direction, I take only the value. So for that I can use the equation for electric field, that is 1 by 4 pi epsilon 0 Q by r square, where r means the distance from this charge to this point P. So for E plus and E minus, I get the equation E plus is equal to 1 by 4 pi epsilon 0 Q by r square plus a square whole square, because this is the distance from the positive charge to the point P, root of r square plus a square. So I get square of this, which means 1 by 4 pi epsilon 0 Q by r square plus a square. And for the electric field due to negative charge, E minus, I mark it as E minus. Remember, it's only the magnitude, that's why E plus E minus, no vector symbol given. 1 by 4 pi epsilon 0 Q by, again the same, we will get root of r square plus a square the whole square, that is Q by r square plus a square. Their magnitudes are equal. Now what we do is, we resolve this electric field at E plus and E minus. This E plus and this E minus I resolve into components along the x direction and the y direction. Those two directions I split this E plus and E minus. So I get, this is the figure for that. Here is E plus resolved into two components. If here is the angle theta, this component will be E plus cos theta, this component will be E plus sin theta. I hope like you remember vector concept you studied in 11th standard. So when this is a vector, if I split it into two components near the angle theta, that side I get the cos component, other side I get the sin component. Similarly, this E minus vector, I resolve, I get E minus cos theta, E minus sin theta. These two I have shown in single figure. You just see this figure. Here is the point P, E plus, E minus, E plus its cos component is here, marked here, E plus its sin component is marked on the top. Same way, E minus its cos component and sin component is marked in this figure. So here you can see E plus sin theta, E minus sin theta are acting in the opposite direction. And we already told E plus and E minus magnitude are equal, which means these two are equal and opposite, they cancel. And these two, E plus cos theta and E minus cos theta, they act in the same direction. They act towards the right side. So these two get add up. So our net electric field is only the sum of E plus cos theta and E minus cos theta. Now we will find what is this E plus cos theta and E minus cos theta if we add up. So you can see here the net electric field is sum of this E plus cos theta and E minus cos theta, which means E are equal in magnitude. So if I write it as E alone, E plus cos theta and E plus cos theta will come 2E cos theta. That's the sum. So 2 times E value I substitute 1 by 4 pi epsilon 0 q by r square plus a square. This is E. Cos theta is that. Now come back to the same figure. I have plus q here, minus q here. Middle point, this length is A, this length is R, and this angle is theta. This hypotenuse is root of r square plus a square. So from the triangle, if I take cos theta, from here if I take cos theta, I get the adjacent side A by the hypotenuse root of r square plus a square. So in this equation for cos theta, I substitute that also. So for my cos theta, if I substitute this equation, A by root of r square plus a square, root of r square plus a square. This root of any quantity I can write as its power as 1 by 2. Suppose if I write root x, that I can write as x raised to 1 by 2. So same way, if I substitute all these, I get 2 into 1 by 4 pi epsilon 0 is here, q is also here, r square plus a square which came from electric field equation, that's also here. Cos theta I substitute as a by r square plus a square all raised to 1 by 2. Now this r square plus a square here and r square plus a square all raised to 1 by 2 here, I multiply, and for that I use a rule x raised to n into x raised to m is x raised to m plus n. You know already this relation. So if I multiply this quantity, I need to add their power 1 plus 1 by 2. I get it as 3 by 2. So that I write here. E net electric field is 1 by 4 pi epsilon 0 p by r square plus a square whole raised to 3 by 2. This part alone I told r square plus a square whole raised to 3 by 2. Now one more thing here I forgot to tell you, that is 2 into q into a. This is nothing but our dipole moment P. So my dipole moment P is added here. I get E net is equal to 1 by 4 pi epsilon 0 P by r square plus a square whole raised to 3 by 2. And one more thing for short dipole. Short dipole means this dipole distance r, distance from the center of the dipole, which is r, is very greater compared to a. In that case, the term a square or a cube or a raised to 4, any term will become very small and we can neglect it. So here in this equation, this a square I neglect. Then I use only r square. So 1 by 4 pi epsilon 0 p by r square whole raised to 3 by 2. R square raised to 3 by 2 is r square into the power will be multiplied. 2 into 3 by 2, 2 will cancel, r cube will come here. Hope you don't need any explanation for that. P by r square plus r square whole raised to 3 by 2 is r cube. And one more thing, you see the direction. The electric field, net electric field is acting towards the right side. Here you can see in the figure, the net electric field is acting towards the right side. Our positive charge was here, negative charge was here. Here is a term dipole moment vector. dipole moment acts in the direction from negative charge to the positive charge, minus q to plus q. See this electric field and the dipole moment, they are opposite. So when I represent the direction, I can give a negative symbol here and express this p as vector. This means my electric field vector E and dipole moment vector P are opposite. So this is the equation for the electric field due to dipole on the equatorial plane.